So this is my demonstration of diamagnetism. And essentially that's a force that's created that repels an object from a magnet, I guess because it creates a weak magnetic force in the same polarity and causes the item to, it appears to float, but it's just basically two magnets repelling, well, like two magnets repelling each other. This little demonstration here is actually based on some ideas or plans that came from K&J Magnetics. I have a link to them in the description, and if you're an educator, they do offer discounts, so contact them for that discount code. This is some fairly strong neodymium magnets, and they're unique in that instead of being polarized this way, they're actually polarized up and down through the middle. I've got them attached north-south, 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 all the way across, and then I've got two little end pieces here. And since these things are really strong, I went ahead and epoxied them into little holes on either end, and then I've got epoxy running all through the bottom. So little pair of metal tweezers, and you can see that they're pretty strong. It's hard to pull those off of there. So they work just like regular magnets. There's nothing special there. But you do need something special when it comes to what you're going to levitate. And that's it right there. It's a piece of pencil lead, but not any ordinary pencil lead. The stuff on the left is pretty much what you can get at the local office supply store. They're generally referred to as polymer or high polymer pencil leads. They're designed for smooth writing and to be a lot more difficult to break. This pencil lead, for whatever reason, I had to buy it from Japan. It's made by Pilot, but I couldn't find it in the States. And basically it's pure graphite, so there's no polymers or anything, any additives to make the pencil lead last any longer. But you can see the brand name there. It's Pilot graphite, and I can't quite read that. My eyes are shot, but you can see that design. It's a 4B hardness, so it's pretty hard. And I've got a couple of examples. The stuff on the right is normal pencil lead, so we'll try that first and see if we can get it to levitate. Trick, because I already know it's not going to. And you can see it, and it just sits in there. It doesn't float. I'm tilting it up and down. Nothing happens. Some real pencil lead. You can see that just sort of hovers right there. And you can see it bouncing back and forth. I think it's bouncing back and forth between the polarity. So what you can see is the magnetic force runs that way, and it's strongest in the middle, and you can see that it's kind of forcing that piece of pencil lead to between the middle of the three magnets there. So if I tilt it up just a little bit, it becomes fast enough and it'll actually float. I'll tilt up this end. You can watch it just float and bounce back and forth. It's pretty cool. It's actually floating about 1 millimeter above that surface. It's hard to see from the glare, but it's floating about 1 millimeter above, and it's pretty frictionless. It's really neat how it works. I'll put a few links to diamagnetism on Wikipedia, and the link for K&J Magnetics where I got these plans. And I think you'll enjoy building this. There's a couple of different versions of this as well out there. If you look it up on YouTube, you'll find a couple of other demonstrations that I think are just as impressive. Thanks.